Hello, my name is Beth Cudney, and in this video I'd like to provide a brief introduction of Six Sigma. Before we move on to what Six Sigma is, we need to first understand what quality is, because Six Sigma has its foundations in quality and continuous improvements. And one of the best definitions on quality is by Dr. Feigenbaum. And his definition of quality is that quality is a customer determination, which is based on the customer's actual experience with the product or service measured against his or her requirements, stated or unstated, conscious or merely sensed, technically operational or entirely subjective, always representing a moving target in a competitive market. And it's important to understand this because as we move forward with Six Sigma, we need to understand the customer's expectations. And we need to understand that those customers' expectations may change and change frequently. And those customers' expectations are not always driven by metrics that you can measure. Sometimes they're actually sensed, and these are moving targets. And even though our product might be a good product, we also have to take into account what our competitors are doing. And so with that, we move into Six Sigma. Six Sigma is a customer-focused continuous improvement strategy that focuses on reducing variation within our processes. And the goal is to achieve 3.4 defects per million opportunities, or essentially no defects in our product design, production, or our administrative processes. As we improve our processes and we reduce the variation, this helps to improve our customer satisfaction, which also impacts our bottom line by reducing the variation. Six Sigma is also a methodology. It's driven based on a 5-phase methodology, which is define, measure, analyze, improve, and control, or the DMAIC methodology. Six Sigma is also a metric based on standard deviation, since standard deviation is a measure of the variation within our process. In addition, Six Sigma is used to target very aggressive goals. Now, one of the aspects of Six Sigma is it really focuses on using a problem-solving methodology. All of the tools that are used in Six Sigma are not new, but Six Sigma takes these quality tools and problem-solving tools and puts them in the 5-phase DMAIC methodology for problem solving, and it incorporates advanced statistical tools. The Six Sigma methods were first perfected in Motorola in the mid-1980s, and in 1985, Bill Smith coined the term Six Sigma. Now, it's important to understand that when we're creating products, or we're trying to improve our processes, or we have a service that we're offering, variation exists in all of these. No two products or services are exactly the same, and so what we're trying to do is reduce the variation within our process by understanding where the variation comes from within our process. And as we reduce the variation, the distribution of our process reduces to the point where we have a nice narrow distribution that's centered around the target, so we have on-target performance with reduced variation. And what this provides for our customers is a consistent product, process, or service time and time again. And as we do this, the basis of Six Sigma is understanding where that variation comes from within our processes and identifying those sources of variation. Our processes might contain many sources of variability, and we can use the Six Sigma methodology to pinpoint where those sources of variation come from and try and reduce the impact of those sources of variation. What Six Sigma really means is that you can fit 6 standard deviations between the mean of your process and the closest specification limits. Now let's take a look at what 3 Sigma means versus Six Sigma. When we talk about a 3 Sigma process, that means 20,000 pieces of mail are lost per hour versus a Six Sigma process, which means 7 pieces of mail are lost per hour. Another example of a 3 Sigma process would be 2 short or long landings at most major airports each day versus a Six Sigma process where there's 1 short or long landing every 5 years. Another 3 Sigma process could be 20,000 incorrect drug prescriptions per year versus a Six Sigma process of 68 incorrect drug prescriptions per year. And finally, a 3 sigma process would mean 5,000 incorrect surgeries per week versus a 6 sigma process of 1.7 incorrect surgeries per week. So you can see a significant difference by going from even a 3 sigma process to a 6 sigma process. One of the 6 sigma benefits is really developing a world-class culture within your organization. So while 6 sigma is based on the measure of standard deviation, it also drives towards improving the culture of the organization such that it's focused on continuous improvement and understanding the customer's expectations and needs. And this helps to develop leaders within your organizations that are truly focused on the customer. And as your organization undertakes 6 sigma projects, these projects are selected such that they support the long-range objectives of your organization. Now with this, there are several benefits to implementing 6 sigma within your organization. As your teams work together to reduce variation and improve the processes to meet or exceed customers' expectations, your employees build a stronger knowledge of those products and processes. And by reducing the variation, you're also reducing defects in your products and services. And this increases your customer satisfaction, which generates business growth and improves profitability. And as your teams work together, this helps to increase the communication and build that teamwork and that culture within your organization. And finally, 6 sigma follows a define, measure, analyze, improve, and control methodology. So no matter what organization you work for, it's a common set of tools. Now let's talk a bit more about the 6 sigma strategy. And again, it's a 5-phase methodology that's define, measure, analyze, improve, and control, also known as the DMAIC methodology. Now as we go through the DMAIC methodology, we go from understanding what the problems are to characterizing where the variation comes from to improving the processes. So as we look at the define phase, we start to identify the output characteristic that's important to your customer and identify the process input and output variables. When we move into the measure phase, we start defining our performance standards, validating our measurement system to make sure it's accurate and precise. And then we move into the analyze phase where we establish our product capability, we define our performance objectives, and we start to identify those sources of variation. In the improve phase, now that we've identified the sources of variation, we can start to screen those potential causes and discover the relationships between our key variables. Using this information, we can also start to establish our operating tolerances to ensure our processes are capable of meeting our customers' expectations. And then finally, in the control phase, we revisit our measurement system to validate it again. We determine our process capability to make sure that our improved process meets our customers' expectations. And then we implement process controls to ensure that we sustain whatever gains we've made from these improvements. So let's take a closer look at each of these steps. In the define phase, we're asking questions such as what processes are involved, who is the process owner, we form our teams to make sure that we have a cross-functional team, and then we also determine which processes are the highest priority to improve. Now, the 6 sigma methodology is a data-driven decision-making methodology. So we need to also determine at this point, what is that metric that supports our decision? We also start to identify how the process is performed and how the process performance is measured. Some of the key tools used in this phase, but not all of the tools, include the project charter, identifying the voice of the customer, a stakeholder analysis, and process mapping. In the measure phase, some of the key questions that we ask are, what are the customer-driven specifications for those performance measures? And given those customer-driven specifications, the team identifies what those improvement goals are. And also, we start to map out the process to understand where our variation sources are coming from within the process. And then a key step in the measure phase is also to ensure that our measurement system is accurate and precise. And with that, we also ask what sources of variability are controlled and how they're controlled. So some of the tools that are used within the measure phase include, but are not limited to, statistics and probability, process capability, and measurement systems analysis, and then finally value stream mapping. In the analyze phase, now that we've identified some of the sources of variation within our process, we ask questions such as, what are those key variables that affect the average and variation of the key performance measures? And we also want to identify the relationships between the key variables and the process output. And once we've identified those key variables, we want to understand if there's any interaction between those key variables. Some of the key tools in the analyze phase are the cause and effect diagram, regression analysis, hypothesis testing, failure modes and effects analysis, and waste analysis. The next phase is the improve phase. Now that we've identified the key variables, we want to improve those key variable settings so that we can optimize the performance measures. And once we've optimized those, we want to know at that optimal setting for those key variables, how much variability is there in the performance measure? So some of the key tools that are used in the improve phase are design of experiments, analysis of variance or ANOVA, waste elimination, 5S, and total productive maintenance. And then in the fifth and final phase, the control phase, this is where we typically monitor the process for 3 to 6 months to make sure that we sustain the gains that we've achieved at this point in the process. While we're monitoring the process to make sure there's no backsliding, this is where we can determine how much improvement that we've shown in the process, how much time or money has been saved, and we make sure we can sustain those improvements. Some of the key tools in the control phase are statistical process control, standard work. We implement training to make sure everyone understands how the new process operates, and we implement standard operating procedures. So now that we've talked about the 5 phases of the Six Sigma DMAIC methodology, let's take a look at the key roles within Six Sigma. And those include the champion, the team members, green belt, black belt, and master black belt. The champion is a person that provides a top-down commitment to the Six Sigma goals. They're typically someone in higher level management or on the executive team, and they're involved in selecting and monitoring the projects to make sure that they're linked to the long-term objectives of the organization. They're also there to deliver support and give really a mentorship type role. Now, the champion is someone at the higher level of the organization that might have some or limited training on Six Sigma. So typically when they're delivering support or they're helping the team in that mentorship role, they're taking on the role of making sure the team has what they need. So if they need access to specific resources or they're having team issues, this is someone that can step in and really help the team in that aspect. Now, the green belt is someone that's trained in the fundamental Six Sigma tools. These tools are typically those tools that relate specifically to their project, and typically these projects are related to their job function. Now, depending on the type of company, as Six Sigma has really grown in popularity, the percentage of green belts might be a large portion of the employees within an organization. The black belts are the individuals within the organization that are leading the major projects. These are also the individuals that mentor, consult, and teach the green belts to make sure that they're staying on course with the various tools needed for their continuous improvement projects. These are the individuals that are promoting the out-of-the-box and critical thinking within the organization as well. Since black belts are well trained in the various statistical tools, they can lead major projects throughout the organization. And so it doesn't have to relate specifically to their job function. They can work on projects in product development, manufacturing, human resources, or various financial operations. And finally, the master black belt is the person that's driving the major projects. These are individuals that are highly trained in advanced statistical tools. And they're the ones that are training and mentoring the black belts. They work with the champions as really as a liaison to help select the projects and then guide the black belts through their project implementation. Typically, there's only one master black belt per business unit or site because you typically only need one person that advanced in the tools that can guide your black belts. Although depending on the number of black belts you have within your organization, typically you have one master black belt for every 10 to 15 black belts that you have within your organization. And these are the individuals then that the black belts would go to for mentoring if they had questions about advanced statistical tools or specific questions relating to their projects. I would like to take this time now to thank you for watching this video. I hope you found the information helpful as a brief introduction to the Six Sigma methodology. And I'd like to wish you the best on your continuous improvement journey. Thank you.